Hey students, lesson 6.6 here. In this lesson, we're going to learn how to solve systems of linear inequalities by graphing and to model real-world situations using systems of linear inequalities. Go ahead and do the vocab section here. I'll check back with you. All right, the idea here when you're graphing a system of inequalities is you want to find the set of points that is both a solution to one of the inequalities and also the other inequality. And remember, when we graphed just one single inequality like this, we actually shaded an area. And so we're going to be shading two areas here, and the shaded area that overlaps will be the solution for both, that is common to both equations. Okay, so in this first equation, it's written in slope-intercept form, and we know that greater than or equal means we need to use a solid line, and my y-intercept is -1, so let's just put a point there, and then my slope is 2, which means every time I go up 2, I need to go over 1, and since this graph is written is using a scale of 2, I'm going to go up 4 for every 2 that I go across. So that'll look like that, and then I'm going to put a solid line there. All right, so that will look like this. And then the shading, one thing you might have noticed is that if it's written in slope-intercept form and it's greater than or equal, it's always kind of above the line of shading, but you could check the point 0, 0 to make sure that's true. So 0 is less than or equal to 2 times 0 minus 1. That's -1, and 0 is greater than, that's true. So the point 0, 0, which is right in here, should be shaded. So I'm going to shade that way. I'll do that with this green color. Okay. So now I have all that shaded. And now I'm going to do my other line, and that's actually written in standard form. So I think I'll find the x-intercept and the y-intercept. The x-intercept is 2, because if y is 0, x would be 2. And so is the y-intercept, too. I think that'd be the quickest way to graph that. There's 2 and 2. And since it's less than, we're going to use a dotted line on that one. So a dotted line, let's use this purple one here. And that's going to go right through there. And then the point 0, 0 would be true because 0 plus 0 is less than 2. That's true. So I need to shade below for that one. And what I'm looking for is a common region overlapping shading. And let's say I use this shading for this. You can see the region of overlapping shading, and I'll just pick a different color for that now, is this region right in here. So it's just that region right there. That is the common solution. All right, you try that. This one, you didn't see all my shading here, but you should have the region that is overlapped shaded area is the area that I've shaded in green. All right, so let's write a system of inequalities to represent this graph. To do that, we need to figure out what the boundary lines are. So I'll just label these line 1 and line 2. And so this is 1 and this is 2. So line 1, we have a y-intercept is -2. And the slope is, looks like we're going up 1 for every 1 we go over. So the slope is 1 over 1, which is 1. And so my equation in slope intercept of my boundary line would be y equals 1x minus 2. But the part that's shaded on that line, the solid line here, and it's a solid line, so we're either going to use less than or equal to or greater than or equal to here. And it looks like we're shaded above this. So if this area was continuing, it would be all of this over here. So it's above the line. And we found out earlier that when it's above the line and it's written in slope-intercept form, that means greater than or equal to. So that line is y is greater than or equal to x minus 2, or that shaded area. Now line 2 is a dotted line. The y-intercept is also negative 2. The slope for this line, you probably noticed for the dotted line that we're going up 1 for every 3 we go across, so that would be 1/3 rise over rub. So my equation of the boundary line would be y equals 1/3 x minus 2. And this is a dotted line, which means I'm either going to do less than or greater than. And the part that's shaded is below the dotted line, so down here. And below would be less than when it's written in y-intercept form. So y is less than 1/3 x minus 2. And that's my system of equations. Go ahead, you try that. All right, we can use the system of inequalities to help solve the problem here. Dog walker earns $15 per hour. She also earns $12 per hour for babysitting. She wants to earn at least $300 next week, but can work no more than 30 hours. What is the graph showing how many hours she can work at each job? All right, let's let x equal the number of dog walking hours and y equal the number of babysit hours. All right, and if I do that, I can then represent an inequality. She cannot work more than 30 hours, so if I add x plus y together, it has to be less than or equal to 30 hours. And the amount of money she wants to earn is at least 300. At least 300 is greater than or equal to 300. And the way we're going to earn that is by getting $15 per hour for my dog walking hours, plus $12 per hour for my babysitting hours. Now, both of these are written in standard form. And so we can just find the intercepts. This first one's pretty easy here, the x-intercept. If we let y equal 0 in this inequality, we get the x-intercept is 30, and the same for the y-intercept. So to graph those, all I have to do is find 30 on my graph. I'm not quite sure the scale yet though, so let's find the x-intercept down here. The x-intercept for this other inequality, if y is 0, then we get 15 times x is equal to 300. So the x-intercept would be 300 divided by 15, which is 20. And the y-intercept would be 300 divided by 12, which is 25. So, so our biggest number on either axis that we need to graph is 30. So let's go ahead and go by 5s on our graph. All right, and so then let's put on the x and the y-intercept for the first equation, and those are 30. And it's less than or equal to 30, so we need a solid line here. Let's make that line a little thicker so we can really see it. Maybe change the colors here. All right, so we got that. And since it's less than or equal to 30, this point here, 0, 0 would work, right? Because 0 plus 0 is 0, and that's less than or equal to 30, so we need to shade below. Now, I don't need to shade into the negatives because my number of hours of working will always be a positive number. All right, and for my other one, my x-intercept is 20, so I'll put that right here. My y-intercept is 25, I'll put that right here. And I'll draw a solid line there. And And let me thicken that line up a little. And we'll make that green. And then since that's greater than or equal to 300, let's test the point 0, 0 here. If I took 15 times 0 plus 12 times 0, I would not be greater than or equal to 300, which means I need to shade a bump for that one. And so my overlapping shading region is going to be right in there. I think I'll actually maybe erase this to make it look better. So any possibilities for number of hours for me working are within this region here. And you can see some of those, like I could do 20 hours of dog walking. That's this point, 20, and 5 hours of babysitting. All right, you try that. All right, I think that's it for this lesson. Go ahead and do the lesson check, and we'll discuss that when we meet next time in class.